Here we supplied power electronic strainer model XPO-PE. Along with this, different types of panels like P1, P2, P3, P6, P20. We have supplied this type of panels along with this. This is master unit. This master unit is differentiated into three parts. One is top board, second one is LSPT card, and third one is RLC card. On top board, different types of voltages such as plus 12 volt, minus 12 volt, 7 to 14 volt, variable 3 ampere, unregulated voltage 17 volt, AC sync voltage. Along with this, isolated supply of plus 12 volt is provided. Here non-isolated drive is also here available on this top board. Here one auxiliary DC supply using 2 SCR and 2 diode is also available. Here one isolated drive and one non-isolated drive. 2 drives are supplied. Here one inverter transformer is supplied having winding 0 volt, 110 volt and 0 to 230 volt, and a secondary 0, 10.8 volt and 12 volt on dual side. Here one lamp having live and neutral or DC plus DC minus. Here you can fit 15 watt bulb or 100 watt bulb. Now here for auxiliary DC supply, the firing pulses are provided from firing circuit for auxiliary DC supply circuit. This is a firing angle port for this circuit, and along with this, here one field failure relay is provided. This field failure relay is applicable when motor experiments we are performing. Here left side LSPT card is available. Now here this is a master unit. Along with this master unit, we are performing different experiments like inverter, cycloconverter, converter and cosine ramp firing. So different firings are available in this LSPT card. Now here first one is a inverter firing pulses. Now this pot is varying inverter firing pulses from 175 Hz to 250 Hz. Now these inverter pulses can be converted into two types, either inverter type or chopper type. Now for selection, here one switch is provided. For chopper, here one chopper duty cycle control pot is provided that will control duty cycle of that inverter frequency from 50% to 90%. Converter conduction angle control for SCR converter experiment. These pulses are controlled using line synchronous UJT firing pulses. Now these are different types of pulses are generated. Along with this, here one cycloconverter experiment pulses are there. Here 6.25 Hz and 12.5 Hz. Along with this, 25 Hz cycloconverter pulses are also available here. Now all these pulses are differentiated by this one pole 6-way switch. Here this switch having 6 positions. As you select the number of position, accordingly your pulse type is selected. One number pulse is selected for inverter or chopper. Second number position is selected for 25 Hz. Third number position is selected either 6.25 Hz or 12.5 Hz for converter experiment. Fourth number pulse position is selected for converter conduction angle pot. Fifth and sixth are related to high frequency and cosine ramp firing. Now after selecting particular position, all these frequency or pulses are come at this 15 pin female connector through pulse transformer and these 2 switches. When you keep these switches at this left side, then this switch will be disconnected. When you keep this switch at right side, it will be in the connection. Now this is about your LSPT panel. Now here RLC card is there. Now here RLC card, we have given different types of loads R, L and C. Here three types of chokes we have provided. One is 4.2, 0, 4.2 millihenry. These two types, two numbers of chokes. This is choke 1 and this is choke 2 of same rating 4.2, 0, 4.2 millihenry, and this is a choke number 3, 0, 100, 200 milliampere. Along with this, one diode, one capacitor, resistor of 10 ohm 40 watt and resistor of 100 ohm 10 watt. Along with this, 4 capacitor banks is provided of 10 microfarad 100 volt and one electrolytic capacitor 200 microfarad 63 volt. This is about your master unit. Now along with this, here is one slot. Here is one slot. That slot is regarding your experimental panel. Now here we are performing the one experiment. Now that experiment is performed using this experimental panel, and the accessories required like pulses, voltage, load are taken from this master unit. Now how to perform experiment, that we will study